Okay, we're going to start reviewing reporting category 5, which has to do with exponential functions and equations. So we're going to look at graphing exponential functions and the key attributes of an exponential function. So first off, we have an equation. F of x is equal to 2 times 4 to the power of x. And so remember your a value, because remember your exponential equation is written y equals a times b to the x power. And so where your a number is, that's going to be your y-intercept. It's your initial value. So if I look where a is, that's where 2 also happens to be in the same position. So my y-intercept is 2. And I'm going to write that as an ordered pair. So I've got 0, 2. Okay, so I know that this is going to cross the y-axis at 2. And then now I need to look at domain and range in the asymptote. And I'm going to go to my calculator to do that. So I'm going to clear my calculator really quick. And I'm going to go to y equals, and I'm going to type in 2, 4 to the power of x. And I'm going to go ahead and graph that. And so it looks like it's flattening out right here at the x-axis. So just to be sure, I'm going to go to second graph. And I'm going to go up where my x's are negative. And if I keep going further to the left, so as I get more negative, I notice that my numbers are getting smaller and smaller and smaller, and they're approaching 0, but they're never actually touching 0. So this graph is actually flattening out at the y-axis. I'm sorry, the x-axis. So if you remember, the x-axis is a hoy line, a horizontal line, and that tells me that the equation is going to be a y equals equation. And what number does it flatten out at? It flattens out where y is equal to 0, okay? And that's that invisible boundary line that causes my exponential graph to curve and flatten out. It's never going to touch this y value, never going to be equal to, so I'm never going to have a y value exactly in my table. Now let's look at domain. So if I think about how far left and how far right, well, it's going to keep going forever left. And then on the right end, it's going up and to the right. So it goes forever in the left, forever in the right. It's using all the x values. So its domain is all real numbers, because there is nothing telling me that I'm going to leave out or skip over any x value. So I'm going to use them all. And remember, you could use that double R for all real numbers. Okay, for range. So I wanted the lowest is going to go, well, if I could draw a boundary line, how far down? The farthest down it goes is 0 on the y-axis, so that would be y is greater than 0. Remember, it's not going to have a bar because it never touches 0. And then if I ask myself how far up, well, remember, this graph keeps going up. It never stops going up, so my range is going to be where my asymptote is. It's going to be y is greater than 0. Remember, I'm not going to have a bar because, again, that graph line does not ever touch that horizontal asymptote. All right, so let's look at our graph here. Again, I want to see the y-intercept. So you can see that this graph crosses the y-axis at 1. So the y-intercept is at the ordered pair 0, 1. And if I want to look at the asymptote, clear my calculator and set it to the side. If I want to find my asymptote, well, it looks like it's starting to flat out again at the x-axis. So it's a hoy line. So remember, that means that my equation is going to be y equals for the asymptote. And where does it look like it's flattening out to? What y value? It looks like it's going to flatten out where y is equal to 0. So it's never going to touch a y value of 0. It's just going to flatten out there. And now I want to figure out my domain and range. Well, if I ask myself how far left and how far right, if I go to the left, I have an arrow which tells me I'm not only going up, I'm also going to the left. And remember, domain is how far left, so it's going to go out to negative infinity. And now if I ask myself how far right, again, I have an arrow, and this time it's just going in one direction because it's flattening out, so it's going how far right. And if it goes forever to the left and forever to the right and it never skips any x values, they didn't tell us to leave out any, I know that my domain is all real numbers. And so for space, I'm going to write it as that double R. And now looking at range, I want to ask myself how far down. And it's going to go as far down as 0 on the y-axis. So I'm going to go ahead and highlight a boundary there because it's never going to go below that. And I'm going to put y is greater than 0. And again, no bar because it's not going to ever touch 0 exactly. It's going to get as close as it can to that x-axis, but it's never going to actually touch or cross it. And then how far up? Well, I answered that by saying it never stops going up. This arrow is going to keep going up and keep going to the right, and the only direction I'm concerned with for range is down and up. And since it keeps going up, my range is going to be every y value that is greater than 0. 0 would not be included in the list. Okay, looking at our first example, we have initially there are 20 bacteria cells in a culture. After 1 minute, there are 30 cells. After 2 minutes, there are 45. So what I'm going to do is I'm going to actually make a table. And remember, time are x values. So I've got 1 minute. I've got 2 minutes. So I know that 1 and 2 are going to go in my table. And then the y values that match up with that, I've got 30 cells. So 30 is going to match up with the 1, and the 45 is going to match up with the 2 minutes. And then do I know how many I started with? I have another number here. It says 20 bacteria cells, and it says initially. So this is telling me my starting amount is 20. Well, what would my time value be? Well, if I'm starting out with 20 bacteria, that means my time has not started. So my time there is x equals to 0 because I haven't started counting or measuring the time yet. Okay. So what I'm going to do is the y-intercept is also your initial value. So I know that my y-intercept is going to be the ordered pair 0, 20. And then there are 20 bacteria initially. Let's try to squeeze all this in, okay? There are 20 bacteria initially. I start off with 20 bacteria. All right, so we're going to go ahead and plot this on the graph. So I've got 0, 20, and then I've got 1, 30. I've got 2, and then this would be 50. So 50 is going to be halfway between. And I don't have any more ordered pairs, so what I'm going to do is I'm going to go ahead and just connect this because I know that this is going to continue to go up some way, somehow. Okay, so now if I look at my asymptote, remember that's that line where it starts to flatten out, or the line where it gets the lowest. And so this is where my asymptote line is. So it's going to be at y equals 20. And this is just as low as it goes. So there will never be less than 20 bacteria. Okay? There will never be less than 20 bacteria because that's what we started with, and it's growing. I'm going to only get more bacteria. All right, so let's look at domain. Again, how far left, how far right. So how far left this goes, this is actually going to go as far left on the x-axis as 0. So I'm going to draw my boundary lines in here for domain, and this is going to be y is greater than or equal to 0 because I have a solid point here. And then how far to the right? Well, again, I run into an arrow. So I'm not only am I going up, but I'm also going to the right forever. So I can't draw a boundary line. So my domain is going to be all y, I'm sorry, that should be x. All x values greater than or equal to 0. And notice I put y here, but it should be an x because we're talking about domain. All right, now let's look at range. How far down? Well, remember we're going as far down as 20. And then how far up? Well, we got an arrow up, so we never stop going up. And at this boundary line, I'm y is greater than or equal to 20. And I can put a bar here because I actually have 20 bacteria. I'm actually going to be able to put that number in a list and use it. So my range is y is greater than or equal to 20.